Hi everyone, in this video we're going to extend our definition of the trigonometric ratios. So recall that the trigonometric ratios so far we defined in terms of a right angle triangle, and if we have a right angle triangle, suppose that this is triangle A, B, and C, then we know, and let's label this as A, C, and B. Well, we know that the sine of angle A is equal to A over C, the opposite divided by the hypotenuse. We know that the cosine of angle A is the adjacent divided by the hypotenuse, which is B over C. And we know that the tangent of angle A is equal to the opposite divided by the adjacent, which is tangent of A is equal to A over B. So our understanding of the trigonometric ratios is in terms of acute right angle triangles. So let's think about something. In previous courses, you've probably been exposed to the cosine law. Now, what the cosine law says is that it says for a triangle such as this one, I'm just going to make up a random triangle. And in this case, this triangle is not a right angle triangle. So you might have derived this in previous courses, but let's say if this is the side length A, and actually let's label this as A, B, triangle A, B, C, and let's call this side length C. Actually, you know, let's give it some values here. Let's say that this is 120 degrees, and let's say that this is I don't know, like 6 units, and this is 7 units. So in a previous course you would have probably solved this triangle before, and you likely said that a squared is equal to b squared plus c squared minus 2bc cosine of angle A. And that's the cosine law, if you recall. Now, you probably went about solving this, and you can because you can plug in a bunch of numbers into this equation, and we've got that a squared is equal to I don't know. Let's see here, 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 120 degrees. Now, here, well, let's think about this. We know that the cosine of an angle is the ratio in a right angle triangle. That's what you were told. It's the cosine of angle A in a right angle is just defined for a right angle triangle, and that was that it's the adjacent divided by the hypotenuse. But here we've got the cosine of an angle that's 120 degrees, and based on the definition that we've been given, how can we have a right angle triangle that has an angle that's greater than 90 degrees? And the answer is that, you know, based on the definition that you were given in your previous courses, you know, cosine of 120 degrees is really meaningless. Because if you just think about it in terms of acute right angle triangles, you don't have an angle of that's greater than 90 degrees in an acute right angle triangle. You can't, because the largest angle is the 90 degree angle. So we're going to now extend our definition of the trigonometric ratios, the primary trigonometric ratios, to be able to figure out what cosine of 120 degrees actually is. And we'll be able to figure out what the primary trig ratios are for actually any angle, even angles that are you know, beyond obtuse angles, and they're beyond angles between 0 and 360 degrees. So let me go ahead and get rid of this because I'm going to need some space to write. So let's say let's suppose that I've got let's suppose that I have a circle drawn here, and the circle has radius r. Okay, so this is r, this would be negative r, this would be negative r, and this would be positive r. Actually, let's do this in terms of the unit circle first. Okay, so let's suppose we have the unit circle. So this is radius 1, this is 1 unit, this is negative 1 unit, and this is negative 1 unit as well. This is the origin, which would make this coordinate 0, 0. So let's go ahead and we'll draw a regular angle in the unit circle, and let's say that I have, this would be, let's say that I call this point here, the coordinate of this point, let's say I call it x, comma, y. And let's draw a right angle triangle. Let's call this angle theta. And let's draw a right angle triangle with, let me redraw that in a different color. Okay, so if I draw a right angle triangle for this angle that I've drawn in standard position on the unit circle, notice something. The distance between this point and this point would be just the x coordinates, so that would be x. And the distance between this point and this point would be the y value. So if I wanted to figure out what the sine ratio was for theta, I would say that it's equivalent to the opposite side length divided by the hypotenuse, which is just y over whatever the radius of this circle is. So y over r. Now we already said that that the radius here, since this is a unit circle, the radius is 1. So we know that sine theta, this would simplify to sine theta is equal to y. Now, the cosine of theta would be equal to, the cosine of theta would be equal to the x coordinate divided by the radius. And since this is a unit circle, the cosine of angle theta would just be equal to x. And the tangent of theta would just be equal to the opposite side length divided by the adjacent, so just y over x. Okay, nothing too interesting here, and this follows all of the, the rules that you were given for. This follows all the rules that you were given for right acute angles that you were told in your previous courses. So where this starts to get interesting is, imagine that now this angle kind of goes beyond an angle that's it's no longer acute. Now we have an obtuse angle, or an angle that's greater than 90 degrees. And let's redraw this. So imagine now we have our angle drawn like this. And this is x, comma, y. Well, now I can use the definition of the trigonometric, or I can use the trigonometric ratios that I drew in the first quadrant. So pretend that this is quadrant 1, or say that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So now if I draw an angle theta, I'm going to define the sine of angle theta as the y value divided by the radius. the cosine of theta will now be equivalent to the x value divided by the radius. The tangent of theta will be equal to the y value divided by the x value. Now, how is this different than what we've seen previously? Well, now I see that if cosine of theta is defined as the x value divided by the radius of this circle, then the cosine of theta in the second quadrant is negative, because x can be negative in the second quadrant. Y is still positive, but x is now negative. So now this kind of gives us a way to extend our primary trigonometric ratios for angles that are beyond 90 degrees. So this is our new definition for the primary trigonometric ratios. Sine of theta is equal to y over r, cosine of theta is equal to x over r, and the tangent of theta is equal to y over x. And for the unit circle, we have that sine theta is equal to y, cosine theta is equal to the x coordinate. So something to note here is that if the terminal arm is drawn in the second quadrant, the cosine of theta is going to be negative, and the sine of theta is going to be positive. The tangent of theta is going to be negative in the second quadrant because the x value is negative and the y value is positive. If you have an angle in that is drawn in the third quadrant, so let's say that this is point x comma y, and this would be angle theta. Based on how we've defined the sine ratio here, in the third quadrant the y value is negative. So the y value divided by the radius would be negative, because the radius is always the radius is a distance and it's always positive. So the sine of theta is negative in the third quadrant. The cosine of theta is negative in the third quadrant as well, because if you take the x coordinate and divide it by the radius, which is positive, you will get a negative value. And the tangent ratio in the third quadrant is positive, because y is negative in the third quadrant and x is negative. A negative divided by a negative would be positive. And in the fourth quadrant rather, let's suppose that we have an angle here. And this coordinate is x comma y. Then this angle theta here, the sine of theta would be the y value divided by the radius. The y value is negative in the fourth quadrant. So the sine ratio of an angle that's in the fourth quadrant is going to be negative. The cosine ratio of an angle that's in the fourth quadrant, let's see, x is positive in the fourth quadrant, so x over r is going to be positive. So the cosine ratio is positive for an angle that's in the fourth quadrant. And the tangent ratio is a negative y value divided by a positive x value, which is going to be negative in the fourth quadrant as well. So we've got a rule here for determining whether each trigonometric ratio is positive or negative in a given quadrant, and it's called the cast rule. So in the fourth quadrant, the cosine is the only primary trig ratio that's positive. In the first quadrant, all of the primary trigonometric ratios are positive. In the second quadrant, only the sine ratio is positive, and in the third quadrant, only the tangent ratio is positive. So this is called the cast rule. Okay. So next we're told, using the unit circle, determine the sines of sine 60, cosine of 240, tan of 350, and cosine of 490. So the sine of 60 degrees is this angle angle is in quadrant. This angle is in quadrant 1, therefore positive. So we have that sine of 60 degrees is positive. Cosine of 240 degrees, what quadrant would that be in? Well, let's look. Let's redraw this. 240 degrees, let's see, that this is 180. The terminal, when the terminal arm is drawn to the to -1 on the unit circle, then that's 180 degrees. So we are going 60 degrees past 180 degrees to get 240. So that's in quadrant 3. In quadrant 3, the cosine, the x value is negative. So since the x value is negative in quadrant 3, that means that cosine of 240 should be negative because it's in quadrant 3. And let's see here. Next, we've got the tan of 350. 350 degrees is in quadrant, well, let's see here. Let's draw this out again. So here we've got to go from the initial arm to the y-axis is 90 degrees, then 180, then 270, and then 360. So we're, for 350 degrees, we're 10 degrees away from a full rotation. So the terminal arm is in the fourth quadrant for tan of 350 degrees, and the y value is negative, the x value is positive. So that means that the ratio between the y value and the x value in the fourth quadrant is going to be negative. So this is in quadrant 4. And lastly, we've got the cosine of 490 degrees. So the cosine of 490 degrees, and let's think about how to draw that angle. Let's sketch that out. So 490 degrees, well, that's a full rotation. So that's, we've gone 360 degrees. We've gone all the way around the unit circle with the terminal arm. And then let's think about this. We have to go, if we go another 90 degrees, that takes us to, well, let's see here, 360 plus 90 degrees is 450, and we're going 40 degrees past that, so that would be about there. So we've gone around and an additional little bit of rotation. So 490 degrees puts us in the second quadrant. So the cosine in the second quadrant is negative because the x value in the second quadrant is negative. Since the x value in the second quadrant is negative, the x value divided by the radius of the circle is going to be negative. That is in quadrant 2. In the next video, we're going to look at how to actually calculate the trigonometric ratios of angles that are greater than 90 degrees.